As I write this, fires are ablaze around the world, devastating the environment and the lives of people. There are wildfires in Canada, California, Albania, Croatia, and in 5 regions of Russia. But what exactly is a wildfire? And what is exotic behaviour? Well, a wildfire is an unusual or extraordinary free-burning vegetation fire. Wildfires may have been started intentionally, accidentally, or by nature itself due to lightning strikes, but the consequences are the same. They have huge negative impacts on our society, economics, and the environment. Another bit of terminology that I keep coming across and which needs explaining is that of extreme wildfire behaviour. Wildfires can be assigned levels according to how they are behaving. An extreme wildfire has a high rate of spread. Its flames are travelling through the branches and leaves on trees, as well as through the shrubbery, unaided by the blaze on the ground. It also has fire whirls, which are vortexes of hot air and gases rising from a ground fire. These carry debris, flames, and smoke into the air. I was intrigued when I read about some of these fires having exotic behaviour and wondered what on earth that was. On further research, I discovered that a form of exotic behaviour is for a wildfire to produce extreme flaming and smoke emissions that develop into a fire cloud chimney that reaches into the upper troposphere or lower stratosphere. These giant, fast-moving fires are so powerful they create their own weather systems. The intense heat of the fire generates hot air that rises due to convection, and water vapour condenses on the ash, forming a grey or brown cumulus cloud. If the upward heat and moisture continue to intensify, the cumulus clouds evolve into pyrocumulonimbus clouds, which can reach heights of 50,000 feet. These types of clouds are also generated by nuclear bomb blasts and volcanic eruptions. The particulate mass injected into the stratosphere by pyrocumulonimbus activity as a consequence of wildfires can rival or exceed that of many volcanic plumes. These pyrocumulonimbus clouds cause meteorological phenomena such as tornadoes. In some cases, these clouds can develop into a thunderstorm that has no significant rainfall but ice particles in them that can help to create lightning, which in turn increases the risk of generating more and larger fires. Over the years, the frequency of these clouds developing has risen significantly. For example, last year, when Canada suffered from a particularly bad wildfire season, 140 of these clouds developed, whilst the average is usually around 50 per year. The problem with these clouds is that they remain tethered to the fire that produced them. Severe updrafts and downdrafts can create rapid fire spread, spewing embers and lightning that continue to fuel the fire, and the direction of the fire can change rapidly. They also occasionally trigger fire tornadoes. These form when the updraft twists and stretches the air that is being sucked into the sky at high speeds. They only last a few minutes and reach no more than 150 feet, but reach wind speeds of up to 140 miles an hour, seriously damaging anything in their path. Pyrocumulonimbus clouds tend to form in the afternoon when the fire is at its hottest. As the weather cools in the evening, the cloud can collapse, creating a downdraft of heavy smoke, and embers fling sparks miles ahead of the main fire. So much smoke is produced that one would think it was nighttime, and visibility is reduced so much that firefighting aircraft cannot be used. The erratic behaviour and intense heat of these fires with exotic behaviour make it exceedingly dangerous and almost impossible for firefighters to tackle. Luckily, not all extreme wildfires produce pyrocumulonimbus clouds, but even without these, wildfires are a dangerous and destructive force. Around the globe, not only are there more wildfires occurring, but there are also more extreme wildfires. In fact, the number of extreme wildfires has doubled over the past 2 decades. And not only are they becoming more frequent, but also more intense in places such as California, Australia, and the Mediterranean, with extreme fires in recent years releasing twice the energy of those classified as extreme a few years ago. In many areas of the world, the fire season has expanded significantly since the 1980s. On average, it has lengthened by 27% globally, with increases particularly pronounced in the Amazon, the Mediterranean, and the western forests of North America. Fires are also occurring in areas that historically were not prone to intensive fires, such as the Arctic tundra, the Amazon, and parts of Northern Europe, which have experienced record-breaking blazes in recent years. So why is the planet experiencing more extreme fires, and more of them displaying exotic behaviour? Well, it is due in part to climate change, but also to the change in our land use. As humans, we can increase and decrease the chances of a wildfire occurring by how we use the land. Agricultural land reduces the risk of fire, as highly flammable grassland vegetation of savannas in Africa, Brazil, and northern Australia are cleared. Conversely, land exploitation and deforestation have increased fire occurrence in peatlands and forests. In recent years, agricultural land in some parts of Europe have been abandoned, leading to excessive vegetation growth that has increased fire risk. And in the US, natural lands are being converted into wildland-urban interfaces, where homes and other man-made structures intermingle with trees and vegetation. It is estimated that in the US, 1 in 3 houses and 1 in 10 hectares are situated in these areas, and they have a high fire risk due to human ignitions. But the main problem is climate change. Our planet is warming and rain patterns are changing, resulting in drier vegetation, which is easily combustible. Vegetation that would not usually burn, such as rainforests, permafrost and peatland, are also drying out and becoming combustible. It is estimated that the number of days when an extreme fire is possible has become 54% more frequent at the global level. On these days, temperatures are particularly high, recent rainfall and humidity is particularly low, and winds are capable of fanning a blaze. Wildfires are having a huge impact on human health, with a recent study indicating that 50,000 people have died prematurely in California over a decade due to exposure to toxic particles in wildfire smoke. There are also consequences for other species of animals and plants due to a loss of habitat and not being able to escape the fire. The wildfire in the Pantanal in June, the world's largest tropical wetland, destroyed 440,000 hectares of this precious habitat and left millions of animals, plants, insects and fungi dead. Not only can wildfires reduce biodiversity, but they are adding more carbon dioxide into the atmosphere. There is a feedback loop between climate change and wildfires. Carbon stored in forests and soil is released into the atmosphere as carbon dioxide when burnt, and as we know, carbon dioxide is a greenhouse gas. It has been estimated that wildfires in 2021 released 1.8 billion tonnes of carbon dioxide into the atmosphere, compared to about 38 billion from fossil fuels and industry. Not an insignificant amount. Sadly, with global temperatures on our planet still increasing, it is predicted that the frequency of extreme wildfires and those with exotic behaviour will continue to rise, and as a consequence, carbon dioxide emissions will also increase, further enhancing global warming. In subsequent videos, I will be discussing the impact our changing climate has on individual species such as polar bears, as well as whole ecosystems such as coral reefs. I hope you will join me on this journey of discovery and learn about our amazing one world and how important it is to do whatever we can to save our beautiful planet and ultimately ourselves from this crisis of our own making. If you have enjoyed this video, then please like, subscribe and share with your like-minded friends.